Hello, I hope everybody's doing well today. My good friend Zach asked me to do a quick video reviewing the content of this week's section is all about logs. So we're going to do that. First of all, logs, the way you read this is log base 5 of 25 equals 2. That's how you read that. Log base 5 of 25 equals 2. And what logs are all about is figuring out what power of the base gives you we call that the argument. What power of the base gives you the argument? What power of 5 gives me 25? Okay? And the answer to that is 2. 5 to the second power gives me 25. And that's what logarithms are all about. They're the sort of the inverse operation of exponents. So when I was a kid, my Algebra 2 teacher, her name was Miss Holly. And she taught us this thing she called the Holly loop, which I always remember. And so you take the base to the exponent, or to the other side, base to that, and gives you the argument. So 5 to the second equals 25, right there, using the Holly loop. What power of 5 gives me 25? That's what log base 5 of 25 is asking, and the answer is 2, right there. Log base 5 of 25 is 2, so 5 to the second equals 25. That equation is equivalent to log base 5 of 25 equals 2. This is called the exponential equation, and this is the logarithmic equation. I think the quiz this week asks you, hey, what's the logarithmic equation for this exponential equation, and vice versa. And that's how you think about that. Now, the second idea for this unit, or this week, is the idea of there's no base here. That's called the common base, or the common logarithm. And when there's no base, there's a little 10 there. That's implied. The 10's implied when there's no base. So this question's saying, what power of 10 is going to give me 1,000? And it's saying 3, because 10 to the third power gives me 1,000, right there. 10 to the third power equals 1,000. So when there's no base, the base is 10. When there's no base, the base is 10. Finally, the last idea of this lesson was called the natural logarithm. A natural logarithm. And the natural logarithm occurs when the base is e. Now, you'll never see it written like this, though. You'll never see log base e of 5. That's not the way we write it. Instead, we write ln 5. And we don't say ln, we say natural log. So ln 5 is read natural log of 5. And it means log base e of 5. Okay? So natural log of 5 is asking e to what power gives me 5. And if you remember from last week, e is a number, and it's approximately equal to 2.718. It's approximation. It's an irrational number, so it keeps on going forever. But this is saying, what power of 2.718 gives me 5? Natural log of 5, okay? What power of e gives me 5? So another example, natural log of 3 equals x is asking e to what power gives me 3? E to the x power gives me 3. That's what it's asking. So if you had to go from here, sometimes we're asked to go from the exponential equation to the logarithmic equation. Well, if it's an e, then we know it's going to be the natural log. And you're saying, what power of 3, what power, natural log of 3 gives me x, is what power of e is going to give me 3. So we'd write it like this, e to the x equals 3. Now we had to go this way. We'd say, okay, well, the natural log, because it's an e, natural log is e, so we're doing the natural log of this part equals the exponent. Natural log of this part equals x. What power of this thing, what e to what power gives me this? So that's how we interpret natural logs. I hope that makes sense. If you have any questions, if this wasn't a good enough video, send me an email, and I'll try my best to answer it for you. Good luck. Bye.